Welcome to Chapter 13. This is a neutralization problem. It's asking us to calculate the concentration of hydrochloric acid, hydrogen ions, barium hydroxide, barium ions, hydroxide ions, as well as calculating the pH and pOH and figuring out if the solution is acidic, basic, or neutral when 50 milliliters of 0.240 molarity hydrochloric acid is mixed with 50 milliliters of 0.200 molarity barium hydroxide. Whew, okay. Well, let's just use our trusty steps that we've been using for a long time now. Step 1, identify what you're working with. Identify the major species. In the last problem we did, the Does This Make Sense video, we included water in our major species. That was only because the concentration was so incredibly low. Here, these concentrations are not very low, so I'm going to leave water out. HCl, which is a strong acid, and if you don't know that, shame on you. And then, no, it's okay. Just go learn it. Barium hydroxide. So this, is it a strong or a weak base? Hopefully you said it was a strong base, and if not, make yourself some flashcards. Memorize those strong acids and bases. Okay, step 2, as usual, we're going to write out our reaction. So for this one, when you're dealing with a neutralization problem, you can, let's write out the reactions like this. We'll do what we usually do, where we write out hydrogen and chlorine, and we'll write out BaOH2, and it's strong, so we'll end up with barium and 2 hydroxides. But what's also helpful to include on these guys is the net ionic. And for a strong acid or base neutralization, this could be an annotation. For a strong acid or base neutralization, the net ionic is always, always, always H plus OH minus reacts to form water. So if you were to write out the net ionics, or write out the ionic reactions, the total ones for each of these, you would be able to add them together and get this net ionic. So that's cool. We'll use it later. Step 3, we would usually write an equilibrium expression. Do we need an equilibrium expression in this problem? The answer is no, because those are strong acids and bases. We only want equilibrium expressions for weak ones. Okay, next we should check if we need to do a dilution. Do we need a dilution? Well, we are mixing 50 milliliters of one thing at one concentration with 50 milliliters of another thing at a different concentration. So yes, do the dilution. We know our dilution equation. So I'll do this twice, once for each compound. So for hydrochloric acid, I am starting at 0.240 molarity and 50. Oops, I'm going to leave out units. New concentration, I don't know. New volume, let's see. So it was mixed with 50 milliliters. So if it's mixed with 50 milliliters, are we going to add these together? Or is it just going to be 50? We would add them together. So we'd have our new concentration of 0.120 molarity HCl. And this problem asked me for my concentration of it. I know that since hydrochloric acid is a strong acid, it completely dissociates. So this concentration that I'm boxing is initial. There is none left at the end. It completely dissociates. I can also say that I have how much chlorine ions, how many would I get out of this? Well, it's 1 to 1, so it's the same. And since I don't get any chlorines from that barium hydroxide, I'll box that. Okay, now for hydrogens, also 1 to 1. Now I'm not going to box this yet, and hopefully that'll become clear a little bit later. Let's do barium hydroxide. So this one started at 0.200 and 50. Ended at, we don't know, but it had the same volume. So it ends up with a final concentration of not final. After it's been mixed, this is its concentration. However, we know as a strong base, barium hydroxide completely dissociates. So again, this is initial. There isn't any left at the end. Okay, I'm just going to scroll down. Maybe not. Sorry, I'm indecisive. Okay, I can figure out my barium concentration. That is 1 to 1. And my hydroxide concentration, if you wanted to do a mole ratio to figure it out, you could. You could say, I start off with this concentration of barium hydroxide times 1 mole of barium hydroxide for every 2 moles of hydroxide. So you could see that I'm going to have to multiply this number times 2 to get my hydroxide concentration. I'll get rid of that though. You can write it out if you want. So this would be 0.200 molarity of my hydroxide ions. Okay, so again, I'm not going to box that yet, and you'll see why now. We want to figure out if this is going to be acidic or basic. Well, you could probably figure it out just by looking at these concentrations of hydrogen and hydroxide and figuring out, well, which one is larger. However, I'm going to go the extra mile here, and I'm going to... I just realized I switched my colors on that problem. That's strange. I'm going to set up an ice chart. Again, this step, some of you might be able to do this without an ice chart. However, there's no harm in making it. So I'm going to use my net ionic for this. That could be an annotation on a neutralization problem. When you make an ice chart, use the net ionic. On a neutralization problem. Okay, so what is my concentration of hydrogen ions? I've got that from the dilution, so it's 0.120 molarity. I know I have from down here 0.200 molarity of hydroxide, and water. Do I include water in ice charts? Not if it's a liquid. Okay, so now you get to think back to your limiting reactant days. What is our limiting reactant? Well, it's whatever one is smaller. What do I have less of? Oh, it's my hydrogen. So I'm going to use up all of my hydrogen. And since it's 1 to 1, that means I'm going to use up the same amount of hydroxide. So I end up with no hydrogen ions for my hydrochloric acid at the end, and I end up with 0.080 molarity hydroxide. Okay, so step 5 then is, well, let's label if it's acidic or basic first. So what is this, acidic or basic? You'd probably be able to predict that it'll be basic because it has leftover hydroxide ions. We'll let pH and pOH determine that for us, though. So solve for pH and pOH. So I don't have any concentration of hydrogen ions here, so I can't use this to figure out the pH of the solution. Instead, I have to use my pOH first. And I know pOH is the negative log of the concentration of hydroxide ions. So that is equal to the negative log of 0.080. Oops, pOH. So my pOH is going to come out to 1.10. Okay, so that's that. But I want to know the pH, but there's no number here, so isn't there no pH? No, that is not the case. Remember, these guys are aqueous. We have water involved. There is water in here. We have created water. It is sitting in water. And we know that water auto-ionizes into hydrogen and hydroxide. So that means that there are hydrogens floating around in there. And we can use this pOH to figure out how many of them there are. So, let's see. My pH is going to be equal to 14 minus the pOH, which is going to be equal to 12.90. Before I go on, I want to discuss why all those hydrogens went away. Where did these hydrogens from the hydrochloric acid go? What did they get used for? They got used to create water. So those hydrogen ions from the hydrochloric acid got used up with hydroxides from the barium hydroxide. They created water, but then that water in turn released hydrogen ions and hydroxide ions. So that's where our pH is coming from. It's pretty cool. So let's now label this as basic because the pH is greater than 7. Oh, those look like the exact same symbol. There. Basic, because the pH is greater than 7. You could have explained it different ways too, like with the concentrations earlier. And this problem also wants to know the concentration of hydrogen ions. I've got my concentration of hydroxide ions up here. I guess I should have boxed that. That's a 0. Okay, let's get our hydrogen ion concentration. We have lots of different ways to solve for this. I'm going to use the one that involves avoiding logarithms because logs are, I don't know, sometimes they can be confusing. And I don't like making silly mistakes when I can avoid them. So there's that. I know the concentration of my hydroxide ions is 0.080. So that means that my hydrogen ion concentration is 1.2 times 10 to the negative 13. And here you could add yourself a little annotation that says that these hydrogen ions came from the water. So there you go. That is how you do a neutralization reaction with a strong acid and a strong base.